Lesson number 2, the types of software testing. By the end of this lesson, you will have learned about the various types of software testing, and you'll be able to give detailed explanations of each type of software testing. Let's get started. This session will mainly focus on various types of software testing. It will elaborate on testing types like functional testing, non-functional testing, and regression testing. The various types of software testing can be broadly classified as functional and non-functional testing. Let's start by discussing functional testing. Functional testing mainly deals with the verification of the functional specifications of the software. In general, functional testing tells all about what the software system should do. Now, this also ensures testing activity for every feature of the software system and cross-checking of the response from the system. The testing can be performed at various levels, like manual as well as automated, black box as well as white box. It also involves doing a cross-check or validation of the software system or any web portal with the testing documentation like business specifications, test cases, etc. Some examples of functional testing are listed below. To check an online purchase order management system, the vendor can place an order by selecting required commodities after verifying their available quantity. An employee can apply for leave by selecting the required date and the reason, and then by submitting the request to his manager. This slide is going to list the various types of functional testing, including smoke testing, regression testing, sanity testing, pre-user acceptance testing, alpha and beta, and user acceptance testing. Types of functional testing also include unit, integration, and system testing. We've already discussed these types of testing in the earlier part of this session. Let's take a closer look at smoke testing. Smoke testing is used to determine whether there are any serious problems with a piece of software before dispatch of the available build of the software. Let's take a look at an example. Built verification test. Smoke testing can be performed under the following business scenarios: prior to the introduction of the new build, during testing of the bug that was fixed, or during execution of a new change request. It is also essential to confirm that changes made in the code are working as per your expectations. Smoke test can be executed at the developer or the tester's end. Here, developers are testing the patch before release to testing, while testers are testing before moving to the next type. Let's move on. Regression testing is a type of software testing that is intended to ensure that changes or enhancements or defect fixes to the software have not adversely affected the software. The main reason you would use regression testing is customer requirement changes and retesting of any defect after it is fixed at the developer end. Testing ensures that the changes made in the current software do not affect the functionality of the existing software. In short, regression testing is an act of going back to a previous place or state. Using automation tools is helpful during regression testing, as they can save time and effort. Just keep in mind, regression testing can be performed after bug fixing or after any changes have been made in the current build. One of my personal favorites, sanity testing, determines whether it is reasonable to proceed with further testing. This means it deals with auditing the current stage of the testing operations. A sanity test is used to determine if a small section of the application is still working after a small change. Thus, it's a narrow regression test that focuses on just one or a few areas of functionality. It is done at a deep level in the system. The objective is to confirm a small section of application is still working correctly after changes are made in the system. Let's move on. Alpha testing is actual functional testing by the testing team. Sometimes end users are also involved in this type of testing. Alpha testing is done once the application has passed all the levels of testing conducted by the testing team, but small changes may still be made as a result of alpha testing. Alpha testing is done in a final and stable testing environment with the optional presence of the customer. The main intention is to certify the application as tested OK from the testing team side, so that the end user can start accessing the application in their separate environment. Now, let's discuss beta testing. Beta testing comes after alpha testing. Versions of the software known as beta versions are released to a limited audience of end users who are outside of the company. Thus, it's performed in the customer's environment, which is independent from the vendor's test environment. It verifies that the system satisfies the user or customer needs and that it fits within the business process. In beta testing, the end user records all problems encountered and reports these to the developer as basic perceptions. The client's team members will be present in this phase of testing. The customer records issues and problems with the system in this testing. This testing is very important as it's the final round of testing. After this phase, the product will be made available for final commercial use. And I think that about wraps that one up. Now that you have a good understanding of functional testing, let's start discussion of non-functional testing. This is the cross-checking of the non-functional specifications of the system. For example, testing the performance of the software when a heavy load is imposed. The main goal of non-functional testing is to build confidence in the mind of the end user that the system is secure and safe. It's designed to evaluate the readiness of a system according to specific criteria not covered by functional testing. Here, by performance, we mean not only response time, but several other characteristics such as security, scalability, and usability of the application. In short, it's a purely technical testing or technical requirement. Now, let's go over some of the most common non-functional testing types, including performance testing, usability testing, recovery testing, security testing, installation and uninstallation testing, compatibility testing, migration testing, comparison testing, ad hoc testing, walkthrough testing, specification or claim testing, and finally, pairwise testing. Click on Performance Testing and we'll get started. Performance testing is broken down further as load testing, stress testing, volume testing, scalability testing, endurance testing, reliability testing, availability testing, etc. Let's take a closer look at performance testing. The performance measures against which an application is evaluated are processing speed and response time. Performance testing is designed to test the runtime performance of software. It occurs throughout all steps in the testing process test levels. This type of testing ensures that the response time of the system is acceptable. We do this by setting up a considerable load and simulating the system under a production-sized database. The system is tested for response times of several business-critical processes. The exact meaning of performance testing is a process of testing an application in production-like environments with the intent to understand the customer's requirements. So, performance testing provides a quality service to the user in terms of system response time and adequate response speed to achieve the business goals. Let's take a look at some of the terms. The important terminology for performance testing includes throughput, arrival rate, workload, response time, the residence time, and service demand. Click on each of the terms to learn more about them. Throughput is the number of requests processed in a unit of time. The amount of data transferred from one place to another and processed in the specified amount of time can be transactions per second or bytes per time. Arrival rate. It is the same as the system throughput. It is the rate at which requests for work arrive. Testing with this parameter would mean increasing your throughput by adding more virtual users. The number of requests from the users is known as the current workload. Response time can be defined as the time elapsed between submitting a request and receiving a response from the system. Residence time is time spent by the customer at the service center. Service demand is the total average time spent by a request of a given type in obtaining service from a given resource. This is the same as average queue waiting time. Let's take a closer look at the need for performance testing. Performance testing is generally performed to verify that various needs are being fulfilled by the developed software. It helps to identify performance bottlenecks in the applications. This means performance testing helps to identify the screens which respond too slowly while working on an application. It's also useful to predict peak processing ability of the application before development. This measures the maximum amount of data any system is processing without failing. Performance testing also helps in predicting the capacity of the software's systems. We all know that some critical software systems should not be down for very long, as it may cause big problems. Performance testing helps to improve the uptime of such systems. For example, look at an airline ticket booking system. Performance testing enables mission-critical systems to always stay in working status. For example, think of aerospace software. Now let's look at some of the benefits. Performance testing helps to identify the bottlenecks in the software system in advance of the deployment into production. It also supports preparation of the performance metrics that help in better tuning of the software system. And it improves the quality of service in terms of system response to the user's request by providing higher speed and better response time. Performance testing parameters. Let's start this by examining the basic parameter, response time. Response time is elapsed time from submitting the request to the time the response is returned. Next is CPU utilization, which is utilization of CPU memory on certain transactions compared to total memory. Now, memory utilization is total usage of the memory needed for successful completion of a certain transaction. Lastly, throughput is the number of requests processed in a unit of time, or the amount of data transferred from one place to another and processed in a specified amount of time. Let's talk about performance testing parameters at the advanced level. Click each of the advanced measures to learn more about them. Memory can be interpreted in various units, as described in the slide. CPU utilization. This is the utilization of the computer processor for every transaction. Ideally, it should not be more than 80%. The network level parameter references utilization in terms of bandwidth, queue length, etc. We're going to take a look at the performance testing process step by step. Click each of the steps to learn about them. The first step is the test requirement analysis, which involves determination of performance requirements from a response time and resource utilization perspective. The second step is performance test strategy, and planning, which is a monitoring approach that typically includes identification of load generation. After strategizing and planning for performance testing, the next stage is test design and development. This involves preparation of load generation scripts and the setup of the test environment. Performance test execution and results generation includes the execution of test and the capture of the results. The performance test results analysis involves analyzing the results and determining any bottlenecks. The post-tuning testing and results analysis includes verification of the performance measures, and it ensures enhancement in performance. Let's go over the performance testing types. Performance testing can be classified as load testing, stress testing, volume testing, scalability testing, endurance testing, reliability testing, and even availability testing. We're going to discuss these types in the next few slides. Let me introduce you to the wonderful world of load testing. Load testing is one of the types of performance testing which checks whether the system can sustain the pressure of many users accessing the system at one time. The production load is replicated in the test environment in this case, after which the system is tested. Here the load is increased gradually to note the behavior of the software. It simulates the real-time system conditions in terms of loading. It is crucial that load testing be performed before the application goes live. Typical websites like share trading, ticket booking, and purchase portals, etc., can be tested for load testing. Let's look more closely at some of the various causes behind slow performance of the software system. Heavy load on the servers, like the application server or the database server, could be conditions of congestion within the network, or slow processing on the client side, even sudden load impositions. Let's keep moving. Let's examine the need for load testing. For critical transactions, it's important that the system should be able to sustain the gradually increasing load in terms of data and users. For example, the screen which selects departure city and arrival city in the airline booking systems needs to be included in load testing. This will help to better understand the results of the load testing. Some websites are exposed to high-frequency transactions, and for those sites, the load testing is extremely important. It identifies bottlenecks and tries to reduce occurrences of performance degradation in cases of transactions which may be performed multiple times. For example, online money transfers using banking sites. Load testing is necessary for some websites that are prone to a heavy data load. Those sites should not fail or stop responding to heavy loads. Again, think of airline ticket booking sites. Now let's examine stress testing. The type of testing in which an application is burdened with a gradually increasing load until the application reaches its breaking point and stops responding is known as stress testing on the application. Stress testing is done to pull the system far beyond its capabilities and to see how it responds. Compared to load testing, in which the maximum allowable load is generated, stress testing generates a load that is more than what the system is expected to handle. Parameters affecting the system performance include low disk space, insufficient processing capacity, less network bandwidth, even the system configuration, etc. So, stress testing is useful to determine how well or how fast a system can recover after an adverse event. Let's dig into this with some of the environments. Typical stress testing involves actions like running several resource-intensive applications in a single computer at the same time, or loading the server with useless email messages, or maybe making a number of concurrent attempts to access a single website, even introducing huge amounts of data to the system to test it for stress. For example, creating thousands of data sets and importing them using a file import function into the application. Now, why is stress testing going to help us? It ensures that the application being tested for expected load can take on spikes in the load condition. For example, an increase in the rate of transactions. We can then study the impact on the system's resources. Stress testing helps tune and configure the system optimally. It ensures that the system can sustain sudden increases in the load. For example, an increase in the number of users accessing a banking application. Let's get into volume testing. In volume testing, a large number of data is populated onto the database. This process confirms that any value that may become large over time, like a log file, data files, etc., can be accommodated by the program and will not cause it to stop working or degrade its operation. It also verifies the limits of the system capacity and determines if such limits are acceptable to meet the organization's business goals. For example, for any online banking system, it's sufficient to support 1,000 concurrent users working at a single instance. It's beneficial to study the application behavior in the case of increasing load. This helps to determine the overall health. Let's take a look at endurance testing. Endurance testing is also commonly known as longevity testing or soak testing. Endurance testing is executed with expected user loads sustained over a long period of time, with normal ramp-up and ramp-down time. It checks the reaction of a subject under test in a possible simulated environment for a given duration and for a given threshold. Some of the benefits of this: endurance testing helps in uncovering the performance bottlenecks, like memory leaks, which become visible when the system is subjected to normal load for a prolonged time. This testing checks the performance before the application becomes live. Moving on. Reliability testing. Reliability testing verifies the probability or chances of a failure-free software operation for a specified period of time in a specified environment. Thus, reliability testing of the software deals with checking the ability of the software to function under given environmental conditions for a specified amount of time. It considers all precisions of the software. You should know that it may uncover problems related with software design. Also, bear in mind, software reliability is the probability that software will work properly in specified environments and for a given period of time. It will also obtain the raw failure time data for product life analysis. The main benefit of this type of testing is it helps to determine product reliability and whether the software meets the customer's reliability requirements. Why do we need reliability testing? Reliability test can be performed for accident countermeasures. It finds measures to alleviate damages from any accidents that occur. For example, alternative data backup in case of a drive crash. Also, collecting reliability data. It can collect data within permissible limits. For example, proper banking data to test critical banking systems. Even product reliability assurance. It can assure the product is able to perform as per user needs. And finally, it can help with investigating test methods. It can investigate the methods for testing. For example, new testing methodologies like agile testing that may need to be developed. How about availability testing? Availability testing means running an application for a planned period of time and collecting failure events and repair time. Availability testing focuses on aspects like uptime of the application and IT infrastructure. Some of the benefits of this are that it ensures the service level agreement, or SLA, is met by comparing the availability percentage to the original desired percentage. A service level agreement is a contract made between the software service providing company and its client. This contract is a detailed description of the services to be given to the client by the service provider. For example, an airline booking system is expected to be available 24/7, 365 days a year without failure. Now it's time to look at usability testing. This type of black box testing is conducted in order to determine how well the system is understandable by the user. It's meant to check user-friendliness of any software application. It's conducted to check whether system navigation is smooth or not, and to ensure the software is easy to use. It ensures that error messages as well as system output messages are meaningful and simple. Let's begin. What are some of the advantages of usability testing? Well, usability testing helps to judge the response of the end user to the software for any valid or invalid operation using the software system. It can estimate the stress level and the confidence of the end user in using the system. It can also determine whether valid and user-friendly messages at proper user transactions are supported by the system or not. And finally, usability testing helps to judge the number of mistakes the user can make in working with the software system. Now the flip side of the coin, the disadvantages. This approach may need to be sensitive to the culture involved across location. For example, more use of character-based software in Europe rather than Windows-based software. These software users prefer using the keyboard instead of the mouse for navigation of the screen. This may change the focus of the software testing towards usability aspects. It may reduce control over the testing environment. For example, too many cosmetic or usability level defects may cause delay in functionality testing. Let me introduce you to recovery testing. Now, recovery testing, as the name indicates, is a testing activity to check how well an application is able to recover from crashes and other hardware issues, as well as terrible failures. Here, the software is purposefully forced to fail and has to return to its original stage. If the system recovers on its own, then the process of reinitialization is correct. It checks for how the system recovers on its own. This means the process for recovery of the failures happening is corrected. The extent of recovery of software needs to be mentioned in the relevant requirement specification documents. The goal of recovery testing is it should ensure software operations continue after disaster. It should also verify the recovery process and effectiveness of the recovery process. Finally, it should ensure that a sufficient quantity of recovery tools have been developed and are available. Let's examine who needs to be involved in this process. The key participants involved are going to be the senior testing team members, the test analyst, and a management person like the test manager. All of these people would play an important role in any cases of damages to the software system. They should correct them as early as possible. They're responsible for correcting the application to avoid situations like data loss and functional errors encountered in the system. This type of testing is typically used when the user is expecting continuity of the system so that better functioning is possible. Let's look at a couple scenarios that recovery testing can be used in. Loss of data integrity. When the computer is restarted suddenly while an application is running, it is necessary to check that the data is still intact. Or recovery of data accessed using multiple browser sessions. To do this, restart the system while a browser has a definite number of sessions. Afterwards, check that the browser is able to recover all of them. Or even evaluating the adequacy of backup data. The next task would be to verify adequacy of the data backup. Some situations may need separate data backup in case everyday use of the software system may not provide data as needed. For example, with the warehouse management system, which maintains huge amounts of data of inventory and goods, it's preferable to keep proper data backups and additional CD-ROM drives or maybe even on hard drives so that it can be used in case it's needed. Let's go over security testing. Security testing is mainly responsible for system protection. It helps to maintain functionality. 1. Maybe log in to the Windows Server system, which has limited user rights. As a normal user, try to download any software testing tool. The system should not allow the user to download the software. In such a case, only the administrator can download software, as he would have the sufficient privileges. There are some basic scenarios for which it's necessary to perform security testing, like authentication, authorization, availability, confidentiality, or even integrity. Click each of the scenarios to learn more about them. Authentication involves confirmation of the identity of the person. It traces the origin of an article. Authorization is the process of determining if a requester is allowed to receive or perform an operation. For example, the proper login privileges for any software system. Availability assures information and communication services are in place to use when needed for authorized users. Confidentiality is a measure which prevents any disclosure of project information to parties or persons which are not involved in the project as participants or as users. The next one is integrity. It is intended to allow the receiver to determine that the information which it is providing is accurate. The installation and uninstallation testing. This ensures that all features are installed or uninstalled properly. The process of installation or uninstallation establishes whether the system can be installed or uninstalled on different operating systems or hardware without any error. It checks that applications are tested for full, partial, or upgrade install as well as uninstall processes on different operating systems under different hardware or software environments. In this example, let's assume that the user has sufficient install and uninstall rights. Install LoadRunner 11.0. Wait until installation is successfully done. Confirm all the LoadRunner modes like controller, virtual generator, and analyzer are opening and working properly. Let's look at some of the tips for installation and uninstallation testing. While installing the application or product, don't forget to check that the dependent patches or softwares are installed properly. Check whether the installer gives a default installation path. The installer should allow the user to install at a location other than the default installation path if they choose. When the CD is inserted or setup is executed, ideally, installation should start automatically. If the product is a new version of some old product, then the previous version should not be over-installed with the newer version. The installation facility should provide remove or repair options for the software. For the purpose of better maintenance, try to install the application or the software on different platforms, as well as on various operating systems. Here are some examples of the installation and uninstallation testing. Number 1, disk space checking. It's extremely important to check this in the installation testing scenario. Check for disk space availability before and after installation. Do the manual and maybe even the automated methods. Check the system behavior on low disk space conditions while installing. Number 2, test for uninstallation. Before every new iteration of the installation, make sure that all the files written to the disk are removed after the uninstallation. Check for the rebooting option after uninstallation manually and forcefully, not to reboot. Compatibility testing. Compatibility testing is conducted on the application to evaluate the application's compatibility with the computing environment factors, such as operating systems, databases, bandwidth, etc. For example, install an online game on your computer system. It will be installed on the system only if your computer operating system is compatible to the game specifications. Compatibility can be checked by installing the game application on different operating systems, like Windows 98, Windows NT, Windows XP, and Windows Server. In other words, compatibility is how the application works best with external environment factors like operating systems, databases, etc. It typically involves testing how well a system performs in a particular environment that includes hardware, network, operating system, and other software. Thus, effective compatibility testing is needed before releasing the product for the end users to review. Let's look at some examples. Some of the typical examples of compatibility testing are network compatibility, evaluation of the performance of any software system or an application or a website on a network with varying parameters such as bandwidth, variance in capacity, and operating speed of underlying hardware. Now we'll focus on the peripherals part. Here, evaluation is done by checking performance of the system or any application in association with different peripheral devices connected. For example, checking performance of connected printers, fax machines, etc. The next check is about version compatibility. Version means the latest edition of any system, like software or hardware, with some additions, updates, or deletions of the features. It is very important to evaluate performance of a system or application in connection with its own previous or next edition or version. For example, any presentation prepared in Microsoft PowerPoint 2007's version can be compatible with older versions of PowerPoint. This can be done by saving the file as the 97-2003 format. Let's take a closer look at migration testing. What is migration testing, and what would cause us to conduct a migration test? In general, migration means movement from one situation to another with a specific constructive purpose. Similarly, companies are moving their software systems or applications from one platform or operating system to another. Migration testing assures that the data, the infrastructure, and the applications are intact after this transition. The various reasons for migration can be seen as achieving cost savings, license expiration of their hardware or their software, enhance performance of an application, standardize the technology of an application, or even accommodating change in business structure, which could be due to a latest acquisition or a merger that was completed. In this case, the software application may need migration. Migration testing, types and benefits. First, we're going to focus on migration testing types. Database migration testing, in other words, the database is moving from, say, Microsoft Access to Oracle. Testing should be done to ensure that data migration from Microsoft Access to Oracle is complete, and there are no defects arising due to the database migration. Technology migration testing, in other words, from Java to .NET. Here, the goal of migration testing is to ensure that functionality of the software testing remains intact, even after migration from Java to .NET. Operating system migration testing. In other words, the current operating system is Windows NT, and it's migrated to Windows XP. Here, the goal of migration testing is to ensure that all the data, as well as software, is functioning properly after the migration. Now we'll focus on the benefits of migration testing. It improves performance, reliability, and availability of the application. It results in effective cost savings. It mitigates risk, and it helps in better market identity. And on to comparison testing. Comparison testing involves the comparison of positive features as well as weaknesses of the product with previous versions or other similar products. This testing basically compares performance parameters of the software. Some of the important attributes useful for comparing the application are listed in the slide as follows. Key product features, comparative features of applications, for example, Windows-based, Unix-based, etc. Price, the price comparison. How about ease of use, the degree of ease during usage? Maybe performance. Compare performance of applications like durability. reliability, how reliable an application is in comparison with another, and even compatibility with the environmental factors, how the application is compatible with the operating system or browsers in comparison with the previous version. Ad hoc testing. Ad hoc testing is the least formal method of testing. No bow ties here. This type of testing is performed without any planning and formal documentation like test plans and test cases, etc. Now let's look at ad hoc testing under software testing lifecycle. That would be STLC. Ad hoc testing can be performed through the complete test cycle. In the beginning, it helps testers to understand the program and allows early discovery of bugs, while in the middle of the project, in the heart of it all, the data is used to set priorities and timetables, so it helps in better planning of testing activity. Near the end, it can be used to examine defect fixes more rigorously. Ad hoc testing significance. Ad hoc testing got capacity to produce hidden defects, which may come during production. It's the best tool for verifying the completeness of the test to be deployed on the system. It does not restrict the testing process to the test plan and any specific methodology of testing. It's been proven useful when sudden demos of the application are planned or emergency release of the product is to be given. Finally, let's look at walkthrough testing. Walkthrough is the method to conduct informal group or individual reviews of the application ready for release or interim trial release. For conducting the walkthrough testing process, generally the programmer analyst leads members of the development team and test analyst, or the senior tester represents the testing side. In this approach, the participants ask questions and make comments about possible errors, violation of development standards, and other problems, or they may suggest improvement on the article. Walkthroughs can be pre-planned or can be conducted on an as-needed basis, and generally people working on the work product are involved in the walkthrough process. This slide also explains the purpose of the walkthrough testing. It generally will find problems and also provide solutions during the discussion mode. And of course, it explains how the current work product is fulfilling all of the requirements. There are three important people in the walkthrough testing process. There's the leader. That, of course, is the person who conducts the walkthrough, handles the administrative tasks, and ensures orderly conduct throughout. The second person would be the recorder, who would note all potential defects, decisions, and action items identified during the walkthrough meeting, and also generate minutes of the meeting at the end of the walkthrough session. Finally, the author is responsible for the walkthrough meeting and presenting the overall software development process of the product or application, and thus is responsible for completing most of the action items. Let's move on. Specification or claim testing. While developing a product, if a person on one of the teams claims that the application cannot do some task that was specified in the specification sheet, then claim testing is done to test that claim. In this type, the following operations are made on the requirement specifications: a detailed review, gap analysis, and raising the queries, if any. As we learn about pairwise testing in this current slide, we're going to be concluding our long discussion about types and levels of software testing. Pairwise testing is a method of software testing which involves combinations of input conditions. To test the system, a pair of input parameters are used. This will test all possible separate combinations of parameters. The key idea of this technique for software testing is that most bugs in software are introduced by a single input parameter. If it is found that many bugs in your software are introduced by two factors, and you would like to design test cases for software testing by using this condition, pairwise testing would be the answer. Click the button for a pairwise testing example. A bug in the fund transfer features in an ATM system is introduced by two conditions. The first one would be transfer from Bank A to Bank B, and the second one would be the transfer is more than $5,000. In this module, you have learned all about the various performance measures against which an application is evaluated. You've also learned about performance test models, load testing, stress testing, endurance testing, volume testing, reliability testing, scalability testing, availability testing, usability testing, recovery testing. Who could forget the basic concepts of security testing and installation testing? The compatibility testing, migration testing, comparison testing, the ad hoc testing, walkthrough testing, claim testing, and if you made it to the end, pairwise testing. Congratulations! You've successfully completed this module. I'll see you soon.